Hi, my name is David, and I try to play guitar. I'm not very good, as you can tell. One day, I saw a video of blues great Joe Bonamassa getting very technical about his guitar amplifiers. For a guitar player, that guy really knows his stuff about amps. He inspired me to learn more. But to really understand guitar amps, you need to take them apart and put them back together. I watched hundreds of videos. I read all kinds of books. From Craigslist and eBay, I bought a used soldering iron, some old voltmeters, an ancient oscilloscope, and other test gear. Eventually, I built an entire electronics lab. Now, I guess I'm sort of an amp mechanic. I fix other electronics too, and this is my journey. I figured I'd share so others can learn too. I hope you like it, and just as a disclaimer, be sure to consult an expert before working with electricity. Hi, Dave the Amp Mechanic, coming to you from my amp lab in Boston, Massachusetts. A couple weeks back, I posted a video that teaches you how to pick a digital multimeter if you're an amp tech or you're going to be working on amplifiers, radios, and other consumer electronics. As it turns out, not all digital multimeters are created the same. For example, this Klein Tools multimeter is great if you're an electrician or you're just working around the house. Not so good if you're working on amps, radios, and other consumer electronics. So it's really important to pick the right digital multimeter, and I'm going to stick a card up in the corner of the video right now that shows you how to get over to that video in the event that you haven't seen it. Be sure to watch it because it's very helpful in terms of picking the right multimeter. For example, I've got this Agilent U1252B. It really gets the job done. Now, in that video, I talked about a subject called RMS, or root mean square, and it's a very important subject. So today in this video, I'm going to talk about what that is, why it's so important. I'll remind you why you need to think about it when you're picking a digital multimeter, and we'll do a little bit of testing so you can see exactly how it works and how to convert from one form of voltage measurement to another. And this is very important when you're working on something like a guitar amplifier. Now, why is that? Well, when you're looking at the schematic, which you should always do before you start working on an amplifier, it will often show you a bunch of test points throughout the circuit of the amp and what voltages, both AC and DC voltages, you should be observing at those test points. Every schematic is going to be a little bit different. The guy who drew it up and the guy who took the measurements and said, okay, this is what you should see at all of these different test points. They may have used a different methodology for showing you the AC current at those particular test points. For example, they might tell you that here's what the RMS voltage you should see at that test point is. Or they might tell you this is the peak voltage you should see at that test point. Or they might even say the peak-to-peak voltage. So it's really important to know the differences between these three because of the schematic says, well, the peak-to-peak voltage at this particular point should be 10 volts. And you're testing it with your digital multimeter, which doesn't even know what peak-to-peak voltage is. Well, you might get confused. So you need to know how to convert between these different voltages in order to successfully use a digital multimeter on test points that only show peak-to-peak voltage. This is actually a problem I ran into with the work that I was just doing on a Crate Vintage Club 30 amplifier. And so because of that, I'm just going to show you how to deal with that same exact problem so that, let's say you're looking at a schematic and it says, okay, peak voltage at this test point or peak-to-peak voltage at this test point should be X. Well, if you want to be testing those test points with your digital multimeter, then you know how to do the math in order to get back and forth between those two. So pay really close attention here because I'm going to talk about what RMS is, what peak is, what peak-to-peak voltage is, and how to convert. So let's go to the whiteboard. Okay, what we're showing on the whiteboard here is a very partial representation of what you might see on an oscilloscope. Now, why am I showing you this? Because when you look at a schematic and it tells you that the AC voltage you should be observing at some test point is either the peak voltage or the peak-to-peak voltage, also called P to P, well, that is typically what you would observe on an oscilloscope, not on a handheld digital multimeter. And so if the schematic is telling you peak or peak-to-peak and you're measuring your amplifier with a digital multimeter, you need to know how to convert between the two. So when I say this is a partial representation of what you might see in an oscilloscope, let's talk a little bit about what we're showing here. first of all, these horizontal lines, you'll see those on an oscilloscope, they represent levels of voltage. So in the middle, you've got 0 volts, and as you go lines up, your positive voltage is going up this way, and your negative voltage is going this way, and you've got your sine wave here, which represents your guitar signal, or any other signal for that matter, and that's the alternating current. It goes up and goes down, keeps going up and down above and below the 0 volts line. Now, how many volts that you will see per horizontal line going across the screen here depends on how you've set your oscilloscope. For example, in this case, I've set my oscilloscope to what we call 1 volt per division. Each of these is a division. So this is 1 volt, this is the second volt, there's 3 volts. On an oscilloscope, you'll see more lines than this going across. I'm just giving you a partial representation. I'm showing you 1 volt per division, 3 divisions above the 0 volt line, 3 divisions below it. Okay? Now, when you see the indication that you should be observing peak voltage, peak here, what they're telling you is you should be seeing whatever the highest level of voltage or the peak voltage is above the 0 volts AC line. It is the distance between 0 volts and your peak voltage, the top of your sine wave. So in this case, because I'm using 1 volt per division, and by the way, that could be anything. It could be 1 volt per division, 5 volts per division. You have to set your oscilloscope for whichever is the best setting to observe the voltage that you're observing. When we're at 1 volt per division here, my peak voltage is 3 volts. Again, this is alternating current. Okay, so it's the distance between this 0 volt line and the peak, which in this case is 3 volts. Now let's say your schematic tells you that you should be observing peak to peak or P to P voltage. All right, well, that's typically going to be from this peak to this peak down here, or what I think of as a trough. Okay, and there it is right there from top to bottom. And that's typically going to be double your peak voltage. So it's going to be 3 volts plus 3 volts. You have 6 divisions here going between the positive 3 volt and the negative 3 volt line. 6 times 1, because 1 volt per division, that's 6 volts. So in this case, we're looking at 3 volts peak voltage or 6 volts peak to peak voltage. Peak voltage from the 0 volts line to the top of the peak, whatever that is, and 6 volts peak to peak. So like when you're thinking about a good example of when you're looking at the electricity in your house and it says 120 volts, that's actually neither a peak or peak to peak. That is the RMS, or root mean square average. Now what do we mean by root mean square average? Well, okay, that is if you took a measurement at every little point that happens to exist all along this peak area. In other words, you took a sample reading. They call that sampling. You looked at the measurement at as many points as you possibly can all along here. And then you took the average of all of those points. So let's say you were able to measure 500 points. You added up that total volts that you observed at each one of these points, and then you divided it by 500. That would give you the root mean square. So now let's do a little bit of math, because this is really important, because if your multimeter does root mean square averaging, which it should do, you should not get a multimeter that doesn't do it, and I'll explain why in a second, then you need to know the math for computing the root mean square average of, let's say, this peak voltage of 3 volts. And it's very straightforward. So I'm going to get down here and write the formula. The formula in the case of, let's say your peak voltage is 3 volts, is simply this: 3 times 0.707. and that equals 2.12. Okay? So your RMS voltage, your average of all of those points is 2.12 volts, which is, right about there, right? It's just above the 2 volt line. So now, when you see on your schematic that it says peak voltage, then you know that you should be measuring using this formula 3 times 0.707, and on your digital multimeter that does RMS, you should see about 2.12. That is if at the test point, you should be seeing 3 volts peak. Now let's say you should be seeing 6 volts peak to peak. Well, then it's pretty simple. You just take the 6 volts, you divide it by 2, you get your 3, and then again you multiply times 0.707. It will still come out to 2.12. Because all you're doing is you're taking your peak to peak voltage and dividing it by 2, basically cutting it in half to get you to that point, to this 3, and multiplying it times 0.707. Okay? Now, lastly, let's talk a little bit about going the other direction, which is, let's say you need to convert the RMS voltage that you're observing on your digital multimeter back to peak or peak to peak. Let me erase the whiteboard here and we'll show you that calculation. Okay, now let's say we have to go from what you measured on your multimeter, let's say that was 2.12 volts, this point right here, back to peak. So in other words, you don't have an oscilloscope and you're measuring a test point on your amplifier, and at that test point it's telling you that you should see let's say 6 volts peak to peak, and all you have is a digital multimeter that does RMS. Well, then what you do is you take your reading with your digital multimeter at RMS and you have to convert it to peak to see and confirm that you're getting the right voltage at that test point. So you put your multimeter on the test point and it comes back and it tells you that the RMS voltage is 2.12 volts. Okay, great. The schematic says, well, you need to be seeing 6 volts peak to peak. What do I do about that? Pretty simple. What you do is you take the 2.12 and you multiply it times 1.414. Okay? That's going to equal 3. Then, because you're doing peak to peak, not peak, that's your peak voltage, right? So 3 is your peak voltage. You take the 3 and you multiply it times 2 to get your peak to peak voltage, and you'll get 6. So that's a really easy way of converting an RMS observation on your digital multimeter to peak or peak voltage, just depends. Now, why is this all important? Why is RMS the key here? Because all multimeters do some form of averaging when they're taking an AC measurement. If you don't have an RMS multimeter, like the one that I have, the Agilent U1252B, for example, the Klein multimeter that I showed you earlier doesn't do RMS, then you don't know what the formulas are. You don't know if it's 0.707 going one way and 1.414 going the other, right? So that's why RMS is so important. Because a lot of times you're going to see something like, oh, the observation on this test point should be this peak voltage or peak to peak, and all you're going to have to measure with is a digital multimeter, and you're going to have to do some math. Don't make the mistake that I made, which is I looked at the voltage on the chart, and then I put the multimeter on there on the test point, and I was like, oh my God, this is a big mismatch. It really wasn't a mismatch. The problem was that I just wasn't doing the conversions. This is why knowing this is so important. So now, we've done a little bit of the whiteboard, we've done the math, talked a lot about what RMS is, what peak is, what peak to peak is. Let's do a little experiment using my signal generator. Okay, here's our test setup, and anybody can do this if you have a signal generator and an oscilloscope. On the right side, we have the signal generator right here, and it's dialed to 1 kilohertz. So this guy here, these are the kilohertz knobs, is on a 1. Everything else is on 0. So we're at 1 kilohertz. Now, this signal generator puts out approximately 1 volt by default. And so if we look at the meter here, it's telling you it's at 1 volt of AC. It's dialed to the AC. This is my oscilloscope, and we'll get to that in a minute. Okay, what's next? We have the probes of the multimeter right here, and coming out of the signal generator over here, we have the signal coming out, and the black probe is connected to the black wire of the signal is connected to the black probe of the multimeter, the red to the red. So that's how we're getting this reading. Now it's 1 volt. I'm going to dial it up to 3 volts. Let's go ahead and dial it up. Now remember, this is an RMS multimeter, right? So we're seeing RMS. We're not seeing peak or peak to peak, right? So it's at 3 volts. Now what if we thought, okay, we're seeing 3 volts on this, and therefore our schematic says 3 volts, it's a match. That's actually not true, because if the schematic is telling you it should be peak or peak to peak, that's a mismatch. Remember that we said that the RMS conversion, if peak is 3 volts or peak to peak is 6 volts, should be 2.12. So let's go ahead and dial this down to 2.12. There we go, 2.12. So now the multimeter is telling us that we should be observing 2.12 volts at RMS, or root mean square averaging. So theoretically, if we take the same signal and plug it into the oscilloscope, and we set the oscilloscope to 1 volt per division, or even 2 volts per division, doesn't matter, we can do it either way, we should see a signal that maps out to be 3 volts peak or 6 volts peak to peak. So let's go ahead and let's set it to 1 volt per division right here. It'll be just like the whiteboard that we did. And let's move the leads over to the oscilloscope. So I'm going to take the leads off of my multimeter, and I'm going to put them on the oscilloscope. I'm going to take the black lead from the signal generator. I'm going to put it on the black lead of the oscilloscope, and I'm going to put the red lead on the main probe, like that. And there you go. If you look at the oscilloscope here, we can see, hopefully you can see that. I'm going to change the intensity of the what we can see there. You can see that on the oscilloscope we get a nice sine wave, and it's crossing 6 divisions. 1, 2, 3, 4, 5, 6. So this is your peak-to-peak voltage. 6 divisions at 1 volt per division. If I change it to 2 volts per division, it just goes like that, right? So now it's just, still do the math. We can adjust the vertical position a little bit here. And now you can see that it's taking up 3 full divisions at 2 volts per division. That's still 6 volts. Let's go back to 1 volt per division, and let's just center it. There you go. Right? Now we're looking at 6 volts peak to peak. That same voltage on the digital multimeter is 2.12. Let's go ahead and just show you that again. Disconnect the oscilloscope and reconnect the multimeter, and it will confirm exactly what we expect to see. .12. You can see it. Whoops, just dropped my chopstick. 2.12. So there you have it. This is what you need to know about root mean square averaging. The differences between what your schematic might say you should be measuring and what you'll observe on an RMS meter. That is, of course, if the schematic says you should be looking at peak or peak to peak. If it says you should be looking at RMS, then that's perfect, because then you just put your digital multimeter on and you're going to see exactly the same thing as what is expected on the schematic. But if the schematic says something like peak or peak to peak, you need to do your math. And again, that's why you need an RMS meter. You can see this one says True RMS on it. Without that, you don't know what the formula is. You can't do the math because you don't know what form of averaging the multimeter does. So taking this particular Klein multimeter here, you see, it doesn't say anything about RMS on it. So even though we know it does averaging, we don't know exactly what the formula for how it averages is. So that's it for this video. Thanks very much for joining me. I'm sure I made some mistakes. I'll publish them in the show notes. Or if you have comments, go ahead and leave a comment. And if you like this video, please do me a favor and click like, because that makes it easier for other people to find it. And be sure to subscribe if you want to see more videos like this one on how to test amplifiers, radios, and other consumer electronics. I'm Dave the Amp Mechanic from Boston, Massachusetts. Thanks very much.